Picture a quiet high school classroom, long after the final bell has rung. The sunlight is stretching across the empty desks, and we're looking at Mia, a student sitting alone, staring in total frustration at a recently returned math quiz. She's looking at the red ink at the top of the page, feeling that heavy, familiar sink of defeat. 42. That's her score. Ouch, right? And what's really painful about a 42 is that it represents that deeply relatable tension of feeling like you genuinely understood the lectures, you paid attention in class, but you still bombed the test. It's not a 0. It means she tried, but her hand just closed around air instead of the right answers. It's a feeling I think pretty much all of us can relate to when we're trying to learn something challenging. But right under one of the problems, her teacher, Mr. Mizuno, left this one simple, powerful note. Organize the conditions first. And honestly, this completely flips the script. It takes the focus completely away from the sheer panic of blind formula memorization. It tells us that success isn't about perfectly recalling some complex equation under pressure. It's about making sense of the information right in front of you before you ever even pick up a calculator. Section 1. Making the invisible visible. Look, word problems are just way too heavy to hold entirely in your head all at once. So the very first tactical step you've got to take, turn those heavy words into diagrams or tables or even just quick bullet points. Seriously, do not leave a problem only in words. The second you translate a massive paragraph into a simple sketch, you immediately free up your brain's processing power to actually solve the thing. To really prove this point, Mr. Mizuno asks Mia this exact question. Now, if you just read that sentence quickly, your brain probably jumps straight to the numbers, right? 5 options, 4 options, 3 options. Boom, you do a rushed mechanical 5 times 4 times 3. But hang on, that leads straight into a trap, because we haven't actually visualized the conditions yet. Let's actually break these conditions apart step by step. If you draw 3 empty boxes for your 3-digit number, the trap is instantly obvious. The hundreds place, it literally cannot be 0. If it's 0, well, you've only got a 2-digit number. So step 1 actually only has 4 choices. Step 2 also has 4 choices, because 0 is back in the game, but you can't repeat that first digit. And step 3 has 3 choices. By just drawing it out, you reveal the real answer, 48 possibilities, not 60. Section 2, meaning before calculating. So this brings us to literally the most common pitfall in probability, just blindly throwing numbers into formulas. You have to force yourself to pause and ask this exact question before you ever write down an equation. What does this expression actually count? Are you filling positions, choosing a group, rolling a die? If you write down 5 times 4 times 3, you absolutely need to be able to explain what the 5, the 4, and the 3 actually mean in the context of the story. And you know, it is so incredibly easy to mix up permutations and combinations. The absolute best trick to keep them straight is to ask yourself one simple question. If I change the order, does the end result actually change? Think about it. If you're picking a president and a vice president, order definitely matters. That's a permutation. But if you're just picking a committee of 2 people, order doesn't matter at all. That's a combination. This leads to such a beautiful moment in this explainer. When Mia was struggling with a 2-dice probability problem, Mr. Mizuno hit her with this profound metaphor to explain the denominator. He simply asked, "What is the whole world?" The denominator isn't just some number at the bottom of a fraction. It is the entire universe of equally likely possibilities that you are operating inside of. Think about why that mindset matters. When you roll 2 dice, there are 36 equally likely ordered pairs. But Mia, she used 11 as her denominator because there are 11 possible sums, from 2 up to 12. But wait, getting a sum of 7 is way more likely than getting a sum of 2. If you choose the 11 sums instead of the 36 pairs as your denominator, you're literally calculating in the wrong world, and your math is going to completely break down. All right, section 3. Name your mistakes. When you bomb a quiz and get a 42, your first instinct is usually just to hide the paper, right? And if you do review it, labeling a mistake as just careless or saying, "I just didn't get it," gives you absolutely nowhere to go. But giving that mistake a specific name, like saying, "I treated a combination problem as a permutation," now that gives you a countermeasure. You've diagnosed the disease, which means you can finally apply the cure. And here is the exact mistake review format from the source that can instantly repair your mathematical judgment. Just look at how actionable this is. You identify the problem type, you clearly state your exact mistake, you write down the correct judgment, and, this is the crucial part, you create a specific next time prompt. It's a total game changer. It turns a frustrating error into an actual stepping stone for mastery. Section 4, the proof blueprint. So many people are absolutely terrified of geometry because of proofs. Mia thought a mathematical proof had to be this beautifully written essay, some intimidating wall of formal language she just couldn't crack. But Mr. Mizuna literally drew a simple house on the chalkboard to show that a proof is just a blueprint. It's not about beautiful prose. It is all about structural support. You're just showing how the roof is held up by the walls and how those walls are held up by the foundation. Every single claim is basically just a piece of wood holding up the next piece. Here is the perfect step-by-step blueprint for conquering any geometric proof. You start with the assumption. Those are the raw materials you're given. Then you apply a reason. This acts as the bridge, the logical rule connecting your materials. And finally, you arrive at the conclusion. It's a simple, unbreakable chain. Given A because of B, therefore C. The key takeaway here is that every single step requires a reason. We have to stop relying purely on how a diagram looks. You can't just say, well, angle B equals angle C because the picture looks kind of balanced. No way. You have to use the blueprint. Since AB equals AC, the triangle is isosceles. Therefore, the base angles are equal. Boom, you've built the bridge. And finally, Section 5, Beyond the Classroom. Ultimately, the whole point of learning this isn't just to pass a math test. It's to upgrade your mind's operating system so you can navigate a really complex, messy world with clarity and logic. Here is a rapid-fire checklist to keep your logic steady whenever you face a real-world problem. Whether you're evaluating a massive business risk, organizing a huge project, or just trying to make a tough life decision, you do exactly this. You read the situation, you organize the conditions visually, check your assumptions, watch out for your historical blind spots, and explain your reasoning clearly. We'll wrap up this explainer with Mia's beautiful final realization as she leaves the classroom. She realizes that mathematics isn't just about hunting for answers, it's about making the invisible paths of logic crystal clear for everyone to see. By organizing conditions, we're really just building bridges over chaos. So, the next time you face a complex problem in your own life, ask yourself, what invisible path are you going to make visible today?